So now I can very clearly say why information is not energy. It's not a more subtle or unknown form of energy. Why is this not the case? It's so simple, very clear. We could say, well, it's an unknown form, more subtle, more unmeasurable. Of course, but why is it not an energy? Because it does not fulfill the first requirement, the first definition of energy, the conservation law. Why not? These are very, very simple things, but I understand it took me many years to come to this, yes? But they are so simple, and everybody will immediately agree. But it took me years. And nobody out there has ever described why energy and information are not somehow the same. Simply, if I'm talking to you now, we have 2, 4, 6, 8, 10, 11 people here. It takes me a certain amount of energy. Now imagine the whole room was filled with 25 people, so how much more energy would I need? Nothing. So imagine you are now really getting interested in check out the forum, the energetics forum. And then besides you, another 10,000 people get interested in their check out the energetics forum. How much more gasoline do we have to put in our computer to supply all this additional demand? How much more? Nothing at all. Because it's information. Or you can give so many examples. You don't need to use the internet. You could just take a book. So how much more energy is taken out of the book if one person reads it or 10,000 people read it? Nothing. It's the same thing. But if you have let's say, a flashlight, and you want to run it 1 hour, you need a certain amount of battery power. If you run it 2 hours, you need double. Yes? Energy is completely under the law, not only of time and space, but under the law of quantity. And the conservation law is just another formulation of this. So this is really a very simple way to see that we have not realized the most important thing in our life until now. Even science has not even touched it. Because let's say they find in the CERN Hadron Collider, they find a particle which is even more fundamental than what the quarks they have found now. Who now rules this particle? How does it act? How does it react? It's information. What's the length of its time, its lifetime, for example? Because they are this universal, this absolutely elementary particle will be completely symmetrical, completely homogeneous, because it's only one. There's nothing anymore that you can divide. But where's then the information that makes it live 1 trillionth of a second or 2 trillionths of a second? Or when you have radioactive elements, you have 1 billion particles, and after the half-lifetime, only half is still left. But who tells the individual atom that it can decay or it cannot decay? Who tells when there's birds flying together or fishes all in one movement? How tells the individual fish how to move and when to make a movement so that it's not breaking their whole symmetry? This is really it's not being answered. And of course, morphological field, these are just different names. These are different names. All these morphological and intrinsic data field in matrix and astrology and. They are just a name for the same experience, but none of them gives an idea why or how to actually how to change something. Like for one of the few people who really tried to make experiments was Rupert Sheldrake. He said, well, if enough people repeat something, then it gets established on this field and it gets easier for other people, and he did some experiments. But most they just have a name. Now, the core system is not only a system that accesses this informational field, we are having very successful means already now to change things. And even more importantly, I think we have a science developing. Why this is so, why this is possible. So you are one of the really first people that is on this forefront of this amazing new science. It's not a new science, but it's a very old science, but it's in a new form. And I think we have a new way to find out more about how it works. Mm-hmm. So